Good morning everyone. For today's video, I will discuss about the Lewis structures and its symbols. But before that, I will introduce myself first. My name is Elsie Albindanyo from BSED Science 1. So, shall we start? And hopefully, you're still watching and while learning. So, there are some questions that comes in our mind. The question is, why are some chemical bonded molecules and other are an association of ions? The answer of that question is it depends upon the electron structures of the atoms and natures of chemical force within the compounds. Although there are no sharply boundaries, but chemical bonds are typically classified into the three main types. There are the ionic bonds, covalent bonds, and metallic bonds. In that chapter, each type of bond will be discussed and generally properties found in typical substance in which the types of bond occurs. The first bond I discussed is ionic bond. Ionic bond is the electrostatic force that exists between ions and opposite charge. So these bonds typically involves a metal with a non-metal. So next is covalent bonds. Covalent bonds is result from sharing of electrons between two atoms. So this covalent bonds is opposite to the ionic bonds. Covalent bonds is sharing, while in ionic bonds is it exists between two opposite charge. So it is a one and without a non-metallic. So a covalent bond is a bond typically involves one non-metallic elements with another. For metallic bonds, these bonds are found in solid metals. There are three: copper, iron, and aluminum, which each metal bonded are several neighboring groups and bonding electrons free to move throughout the three-dimensional structures. So each band classification is discussed and detailed in subsequent section of the next chapter. Electrons in atoms when they from chemical compounds. Let's remove Lewis symbols. At the beginning of the 20th century, the American chemist Gilbert N. Lewis discovered the Lewis symbol in 1875 to 1946. It has devised a system of symbols. Now it is called Lewis dot symbols, often shortened to Lewis dot symbols. So that can be used for predicting the number of bands formed by most elements in their compounds. Each Lewis dot symbols consist of the chemical symbols for an element surrounded by dots that represent its valence of electrons. Note, there are three notes of Lewis dot symbols. First is convenient representation of valence electrons. The second is allows you to keep track of valence electrons bond formation. And third is consists of the chemical symbols for the element plus a dot for each valence electrons. So today is how to write in the elements of Lewis dot symbols. So first we place that representing in valence. Example is fluorine. For fluorine, it is 7 dots. So we discuss it one by one. For in Lewis dots, we place dots represent its valence of electrons. one at a time around the elements of chemical symbols up to 4 dots. 4 dots are placed to above, below, to the left, and to the right of the symbol in any order as long as which 4 or fewer valence electrons have more than 1 dot in each position. After this discussing, I will show you the example. The next dots, 4 elements with more than 4 valence electrons are again distributed one at a time, each paired with one of the first 4. For example, okay, this is the example. For example, is in electron configuration of atomic sulfur. Okay, atomic sulfur. So the symbol of sulfur is S. Have you seen S? So sulfur in atomic configuration is Na bracket 3s squared 3p power of 4. So this is the electron configuration. So there are 6 valence with electrons. Its Lewis symbols would therefore be, so it is S, we place here. So the valence of electrons of sulfur is 6. So we put the valence of electrons dot, we put here, and second is above. Okay, place it, and next, and this below. And for that, it is to the we double here. Yes. Okay, and that is the electron configuration, the example of electron configuration, a symbol of Lewis dot. So next is fluorine, for example, which with the electron configuration of He bracket open and close, then 2s squared and 2p squared. So beef. So the electron configuration is 7. The number of electron configuration is 7. 5 plus 2 equals 7. So it's 7. Example here is F. So I will show you one by one. First is F. First dot here in above. And the next is F, again F, and we put here how to write. We put here above and the left side. So next is until it is come to 7 valence or 7 dots. Next is first we put above, and the next side here, the left side and below. Yeah, that is the third. So the fourth is above, left side and below, and the right side, the opposite of left. So second is, that's 4 dots of electrons, and the next is first, second, third, fourth, and back to above. So it is 5. 1, 2, 3, 4, 5. This is a 5. And next, so that is 2p5. Yeah, 2p5. That we have more 2f and then that's 6. 1 2 3 4 5 6, so that's 6. Okay, next, last is 7, so that is 7 electrons. So the final is f then 1 2 3 4 5 6 7. So that's how we write or we draw the electron configuration, that's of Lewis structures or symbols. That's the Lewis dot symbols of Lewis. And then next is Lewis used unpaired dots to predict the number of bonds and elements will form in compound. Consider the symbol of nitrogen. The Lewis dot symbols explain why nitrogen. Okay, next is nitrogen. I explain here the nitrogen. Compared by comparing. Nitrogen is N. Okay, with 3 unpaired valence. Nitrogen has 3 unpaired valence. So, tends to form compounds in which it shares unpaired electrons from 3 bands. So, the electron configuration of nitrogen is H E bracket, that's the electron configuration, and 2s second, 2p third. So this is the electron configuration of nitrogen. And the electron symbol or electron dot is N. One we place here in above first, above. And second is this right side, and then Ana. Oh, that's the electron dot, and that's the final electron symbols of nitrogen. Next is boron. Boron, which has also 3 unpaired valence electrons in its Lewis dot symbols. It's also tend to form compounds with 3 bonds, whereas the carbon has 4 unpaired valence, and its Lewis symbols tend to share. So they are sharing. The carbon has 4 unpaired valence, so it is like this. See, and that's the Lewis dot symbols of carbon, unless the boron is 3, so it has unpaired. It is a boron, and this is the carbon. So next is, before this end, I will discuss the hint about the Lewis electrons. So Lewis dot symbols can be used to predict the number of band. Yes, it is a number of band that formed by most elements in their compounds. So it is convenient that it is a way to predict a number, and its basic arrangement of bonds in compounds by using electron dot symbols, which consist of chemical symbols of an element, surrounded by dots that represent its valence electrons. So this is the example of valence electrons. This is the Lewis dot symbols. So, but or yes, it is a group into pairs often placed above, below, and the left and right of the symbols. The structures reflect that fact that elements in period 2 ions tend to gain or share electrons to reach a total 8 valence electrons under compound. So it is called octet rule, or that's it. And that's all. Thank you for watching, and I hope you will learn. Goodbye.